Hello everyone, I'm Dr. Mehraei, and today we are going to talk about functions in C programming. The definition of function in computer science is totally different from the one that we know in mathematics. Basically, in C programming, when we talk about a function, it means that we get some input, maybe we do some calculations, apply some commands, and then we get output. Whatever you could wrote as code before, we could still do it without functions, but functions are nice in order to avoid repetitions. And we did the same for the loops, if you remember. By using that, we could avoid that as well. But this is just one basic advantage that we can mention. There are other advantages as well. Please go through all the definitions that we put for you here very carefully, and you can see we also listed for you the benefits of the functions here. But what I'm going to do mostly is to focus on the examples to show you what's going on there, how we can use them, and how useful they are in our programming. Okay, now take a look at this example. This slide is very important, and whenever you forget about how to include functions in your program, please go back and take a look at this slide again and again. Basically, we could say we add three most important parts as a part of function in our program. The first one is called the function prototype. Here we give the name to the function. This is find max, for example, the name of the function. Before that, we show what's the type of our output. And here inside the parentheses, we can say how many inputs we have, for example, 1, 2. And what are the types of them? Float, float. The first one has the type float, the second one as well. When we put void, it means that most probably we want to print out something as the result, and we don't want to return something in the function. We will talk about it in details. And another part, which is important related to defining our function, is the function header. Inside it, we mention exactly what this function does. So this is the part that we show what the function does, and we get input, and again we give outputs at the end of it. And here, let's take a look at this one, compare it to prototype. Here, this part is exactly the same. Again, you can see float, float, but also we mentioned about two names here, two variables, and we show that inside this function header, what's happening to x and y, and at the end we are printing something. That's why the output is in the format of void, not, for example, float as well. And the other part of the function is calling the function. It means that we just write the name of the function, which is find max, and we use the variables that we already defined in our program in the main function, and we call them by using them. And as soon as you call the function, what you receive here is the output of that function. The output is actually printing something. And as soon as we run it, we print something here. Later, we will learn how we can define this one not as void, but as, for example, float number, so that we can make it equal here to another variable. And then we can again use that variable to do other things in our code as well. So let's see what's happening here. Here, by using the function, if I want to use this function again and again, I don't need to write this code again. So this is very useful that we already defined them, and we can use them whenever we want. And we define lots of them inside the libraries. That's why when we use specific headers in the libraries, then we don't even need to define all of these uh, operations as functions, and it's easy just to call that function. You will see also today as example. So this slide is very important in order to remind ourselves about these three components that we added regarding function. So function prototype, This is the part that we are calling the function, and function header. And also take a look at their position. Later we will mention that we can also add this one before the main function, and we call the function whenever we want to receive the output. And here is the place that we exactly mention what we are doing inside this function. All right, so these are basically the things that we mentioned, and let's take a look at these examples. Like for example, this one. Here we have two inputs as floats and output as void, exactly the same way that we defined the previous example. Or look at this one. We have four different inputs. The first one, for example, integer, next one, character, and the output is float, and this is just the name of this function. So when you are mentioning about the function prototype, we don't mention about the name of the variable, just the variable type. All right, so please go through all of the details that we mentioned for you here carefully. And these are basically the things we just mentioned earlier about calling the function. We have the name of the function and the variables that we are using inside our main function. All right, and the function header, as we mentioned, this is the place that you define what this function does. And after you apply the format that we mentioned, don't forget to put them inside these curly brackets. And we put some reminders for you. Please go through them carefully. And here we can mention about this disadvantage of C, that we don't have nested functions in C program, unfortunately. This is also different from what we have in mathematics. You can have compositions of functions, but here we have a main function, and inside this main function we can define a function as mentioned, and maybe several functions, but we cannot have composition of functions inside one another. You cannot call them at once. This is a big disadvantage of C programming. All right, let's take a look at the second example here. What we are doing here. First, we are defining max count as 4, and we have the function prototype here. So this is the name of our function. The input has float type, and the output is void. It shows that most probably inside the function header, I will have printf. Okay, so we define count as integer, foreign as float, and we start a loop here from 1 to max count, which we define as 4. What's the trend? This is 1 by 1. We add to this initial value of count. So what we are doing inside this loop, we ask the user to enter Fahrenheit temperature. We get this information from the user, and then we call this function. Okay, as soon as you call this function, what this function does, we should go through the function header, and you can see we have the printf statement, and inside we have a calculation, and we announce what's the result of this one inside this printf statement. Right here, we show that C is not always not always how to say rigid. It's flexible time to time. For example, if you use the function prototype inside the main function, it's okay, or you can use it before that. It's better basically to do it inside the main function, because you may get confused by the things that you used before that. We want to use some global variables there, and we will show you also in the last example why they are important. And inside the function header, the way we define the return value thing, everything should be just in terms of single return. And we will talk about it in different examples, that why this is the limitation that we have. And inside the function prototype already saw, we could only define one type for the output. Okay, another example. Actually, this is the same example as we had before, but the difference is related to inserting this output as another variable. So this is possible to do that. When you call a function, this is possible to make the output equal to a value. But in order to do that, you cannot define the output of that function as void anymore. It should be float so that you can make it equal to that one. Another difference is related to the function header. You can see here, instead of printf, now I have returned this value, which is a float variable. So please pay attention to the difference with the same example, but a little different format, as you can see for the function, as we define float as the output. Okay, here are some notes for you. Please go through them very carefully during this week. And about void, if we don't have any specific type for our variable, or basically we are trying to use printf at the end. So in that case, it's nice to use void, or you can just even leave it empty like this. They have the same meaning, no difference between these two. So whenever we don't want to return something, just it's the best to use void. So here, the way we define it, like we have as output integer, we return something actually as integer, but the input is void. It means that not necessarily we are limiting our inputs to a specific variable type. So this is vice versa case, that the input is free, but the output actually it should be defined as integer. All right, we already defined the standard input-output header for you. We use it a lot. And here we know there are other ones as well, which is defined inside C program. And we can use it time to time. There are lots of functions defined in them. And we should know exactly for which function, which header is the most useful one. For example, here there are some functions, and they can be only activated if you use math.h at the beginning. So you should include this header so that these functions will be available for you. Like for example, sqrt, this one get the square root of your argument. Or for example, POW, this one applies the power, like 2 power 3. In MATLAB program, for example, or many other programs, you could write, for example, 2 hat 3 to show that. But C doesn't understand it. It needs a function to run it. And by activating math header included inside your program and use this function, you can also apply power applications as well. All right, so here's another example. We have square function here. So in order for that to be activated, we needed math header. But assume that we didn't include it inside our program. That's why we should define this function ourselves. Let's see how we can do that. Okay, inside our function header, this is the way we define it. The output should be int as the output. We will have an integer number, like the function prototype that we mentioned here. Output is integer, input is also integer. And we don't even need to define the variable here. But if you define it, it's also fine, because instead of doing it inside the main function, for example, in this program, they decided to do it before the main function, and that's why they defined y and integer. You could just mention y, and inside this main function, define y has integer type. Okay, we will have a loop starting from 1 to 10. The trend is 1 by 1. We add to it, and we print the output of this function, which is the square of that value. Right. Another useful function is the random number generator function. This function is very useful because for many programs, we need randomness to be included in our program. Like, for example, dealing with probability questions, we should deal with that. That's why this is very useful in all of the programming languages that we need such functions. Right. Let's see what rand function does here. First of all, we should include this header inside our program, standard library, and by signing this output to I, the value that it can get at the end as the output is a value between 0 and such a number at least. It's also different from other programs. Like, for example, in some programs, the rand function gives you a value between -1 to 1, sometimes 0 to 1. But here, be careful that the output of this function is a random number between 0 and such a number. So in order to make it exactly inside an interval that we are interested in, like for example between 1 to 6, then we can have such a trick. Like for example 1 plus rand mod n, and it will give you always a number as an output between 1 to n. Why is that? Because, for example, if you get a value like, for example, any from 0 to this number, if you divide it by n, the maximum number as the result of this parenthesis, if you can have, will be n minus 1. That's why when you add 1 to it, you can cover all numbers. And this number would be the minimum number that you want to start. If this is 1, okay, then this is 1. If this is 5, then this one can be 5. All right, for example, if you want it to be between 1 to 6, you just insert 1 as the minimum and 6 as the maximum value that you are interested in. And by using this trick, always we can generate the numbers, random numbers that we want. Okay, let's take a look at this example. Pay attention now. We not include only a standard header. Standard library is also included. Why is that? Because we want to run this function. We want to call it. And if you don't use this one, when you call it, see, it doesn't understand what is this function. You should define it yourself in that case. Okay, so in this one, we define I as an integer type. We have a loop, 1 to 20. One by one, we increase the trend. Here also, we should be careful about our initial value. Sometimes you ask me whether we should consider 0 or 1. It depends on you. But when you are defining the end of your boundary, in that case, we should be careful how we define them. If you start from 1 and you want exactly 20 times for a loop to continue, to be executed, then in that case, you have less than and equal to 20. So it will be 1, 2, 3, we continue until 20. If you don't consider equality, okay, it will be only 19 cases. If you consider this one as 0 and you have equality here, then it will be 21 cases. We should be careful, we should practice about them, not to have extra or less repetition inside our loop. Okay, so in this case, we have 20 times. We have this function called, and we will have random numbers from 1 to 6, and we will repeat it 20 times. And this is a good trick also that we use in order to go to the next line after each 5 random numbers. So remember this one, this is a good one to be used in order to organize your output. Right, for this one, we want to throw a die, and we want to count how many times we received 1, how many times we received, for example, 5. This is a nice simulation of throwing a die. Assume that you throw it 6,000 times, and we want to count, for example, how many times we have each case. Now, inside your main function, as we say, it doesn't matter when you define it as void or leave it empty. They do the same thing. So don't be surprised if you see, for example, this is basically the same thing that we used to do. Okay, so initial value of frequency 1, frequency 2, this is our counter to show exactly how many we have ones, how many we have twos. So we start with 0 because we didn't start the experiment yet. Then inside the loop, we simulate it from 1 to 6. We want random numbers. How many times? 6,000 times. And whenever the random number, and finally, when you reserve it in phase, we check it whether phase is equal to which number from 1 to 6. If this is, for example, 1, this is case 1. We defined as a switch, you remember. So when this is case 1, for example, we add 1 to the frequency of 1. So if it happens to be 5, we add 1 to this. So we define cases like that, and don't forget to put a break here. So whenever, for example, this is case 1, and we add 1 to it, when we see this break, it means that we get out of this switch. We don't care about other cases. So we define for all the cases, as you can see, and you can simulate exactly the numbers of them, and you can print out the frequencies for each case. The rand function is not as random as you think. The numbers are actually generated before once, and every time that you run this program, it will give you the same results. So we want to actually have different trials time to time. That's why it's nice to define another function to overcome that problem. And that function in C program is called srand. In this case, we specify exactly from which point of our sequence we can start. For example, in rand function, assume that our sequence is like this: 1, 5, 10, 6, and so on. Every time I run my program, this is the numbers that I receive, and that's why we will get the same result. So if I seed this number, this sequence somehow by using srand, like to say, for example, I want to start my sequence from the second number. Like, for example, if it was 1, 5, 10, 6, I want to start from 5. So I will have 5, 10, 6, and so on. That's why we can see that function so that we start from a specific part of the sequence. And this one is very useful. So we can have a strand and see it usually as a positive integer. And we can start our generating our random number from a specific part of our sequence. Another application is regarding to time, and you can see the example here, but we should be careful that we should include time header if you want to apply it for the case of time. Okay, now let's see another example. Okay, in this one, we included two headers: standard library and standard input-output header, as we usually have, because it includes the standard statements like printf and scanf commands, so they are already there. Okay, so inside this main function, we define I as an integer. This one is new, unsigned seed. It means that we have a positive integer now. Whenever you want to have only positive integer, so it's nice to define it as unsigned, and this is the name of the variable. Okay, we ask the user to give us the value of this variable. So the user gives you that, and as soon as you receive it, you can insert it inside your srand function. And that's why every time you run this program, you not necessarily receive the same answer. Now we are starting our loop from 1 to 10. So 10 times we are repeating something. Let's see, what is that? Okay, so for 10 times, we are generating random numbers. This one, you see, it is rand, not srand. We already use this one so that we specified exactly which position of inside my sequence, inside my rand function I can use. Here I can use again rand. So from 1 to 6, 10 times I'm generating random numbers. And again, I use this trick so that you can go to the next line. And depending on which number the user gives as the seed, you can see the random numbers could be different. Like, for example, in case of 67, we start the sequence from this position, and you receive these numbers as your random numbers between 1 and 6. If the user gives this number, we have this one. If the same number as the first case, you see exactly the elements are the same. So that's the reason we use srand function in order to seed it, in order to change the position inside our rand function. So whenever you run it, you start from a specific part of your rand sequence, and this srand function, as you can see, is very useful. All right, the next topic is related to storage classes. I prefer to show it in the last example to see what do we mean by static storage, but you guys please go through the details. And for the block also, I will show you why this is important inside this example. All right. So please pay attention to this example. This one is very important. At once, I don't expect you guys to get it right away. At the beginning, it looks a little confusing. So you should go through this example again and again to see the differences. And at the end of it, also we showed you the output. So it's nice to just keep looking at the output and the example again and again to see what's going on here. So let's start it from the beginning. Okay, first thing first, we define the function prototypes. In this case, they prefer to define everything before the main function. As we said, this is possible either to define it here or after that. Okay, so by looking at the prototypes, I understand that at the end I will have a printf case inside my function header. And let's see, these are just the names of the function, as you can see here, and we should take a look to see which function does exactly which operation. Before starting our main function, you can see here that we define a variable before going through the body of our program. Here we define x equal to 1. In this case, when you define it before the main body of your program, we call it a global variable. It means that whenever you define something as a block, like for example, you see curly bracket here, opening here and closed here, whatever happens here stays here. So when we get out of the block, it forgets it. It just look at the global variable. The same story about your main function here. When you define something before it, it's there. When you go through the program, maybe x gets different values, but at the end, when you call it, then it will be again the global variable that we are looking to. So let's go through this and see the differences. Now, whenever we define it like before, that x, for example, is equal to 5 inside the main function, it means that this is a local variable that we usually use. But when you use it before that, we call it global. And in this example, I will show you what's the difference. Okay, then suddenly here we have a block. So whenever you start a curly bracket and you close it without giving some commands like for, while, or such a thing, or if statement, then in that case we call it a block. So here inside this block, we define x as 7 and we print out this value. So let's see again from the beginning. First we define x as 1, we went inside this main function, then we define x as 5, then we print out the result of x, which is 5, and then inside this block we print out the value of x, which is 7, and then later when you print out again the value of x outside the block, you will see it should be again as 5. See, 5, 7, 5. So whatever happens inside the block stays there. When you get out of it, it forgets what was the value of x. See, 5 inside the block was 7, then outside was 5. Then we start calling the functions twice. This function, second one, third one, again, first one, second one, and the third one. Let's see what's happening in terms of the output when we do that. And here also, after calling all of them, again we say what's the value of x. We go through all of them inside their headers. They have also their own blocks. So when we get out of their blocks, what we have as x, it will be again the value that we define as our local variable, which is 5 again. So look at the output. You see, again, it will be 5. We don't care what happened between them. Again, here it was 5, so it will be again 5 as we define inside our main function. Okay, so let's go through the functions one by one. When I call this function, which is named useLocal, I should know what's the function header in order to understand what's going on there. Okay, here inside this function, I see x is equal to 25. We print out this value, we add 1 to it, and again we print it out. So 25 and 26 we expected, and it is easy as we did also in our previous examples. But when you call the second function, so here you see we call the second function, and we should take a look at the header to see what's going on. Here we assign value 50 to x, but here this is something new, static int x instead of just int x. What does it do? Let's see through this example exactly what's happening here. So first we say x is equal to 50. We add 1 to it, and again we print it. So we print out the value of x, which is 50 and 51. The block ends here. So when you call it for the second time, here after calling other functions again, we call this one again. So what happens here is that this variable remembers that the last time its value was 51 here. So when you call this function again, it remembers that x is actually is equal to 51, not 50, as we defined it originally in our program. That's why you see this static is very important in order to change its value later when we run this program. That's why this is the main difference between the usual way that we define, for example, int x is equal to something, then static int x is equal to something, because this one can be changed throughout your program as soon as you run and call this function again and again. Okay, so first we call local, then static local, then global. When you call global, let's take a look to see what's happening here. So here we print out the value of x. Okay, we don't define anything beforehand to say what is x. For the previous example, at the beginning of the block, we say x is equal to something, but here we just right away print it out. In this case, what we print out here is the global variable, not the local one, because here we don't know what's the value of that, we didn't define it. So the program goes and look for what was x before when we go through the main function, and that's 1. That's why inside the output what you see is 1 here as the value of x. And what we're doing here, we just multiply it by 10 and again report the result, which is 10. So first time we run it for the local one, and the second time you call this function, they are exactly the same, right? For the second one, we use the static. It means that it remembered the last time we got out of the block, it was 51, so we start from 51. And for the third one, when we have 10 as the result of x, actually we change the global value of x in the program. So first, let me remind you that from the beginning of the program, we consider x is equal to 1 before going through the function. So when you change this value, then it will remember that you already changed the global value. Then the second time that you call this function, it remembers that it was 10 because it should remember something here to report. So it was 10, so you again multiply it by 10. That's why you will have 10 and 100 here. And at the end of the program, before calling out the function, here, before returning to the function here, we have actually, again, the last time we say what was x, and the value that you report here, because we are still inside this block. You see, we are still inside the main function. So it remembers at the beginning of program you define it as 5, not inside any other blocks. So it's very important, guys, to notice that whatever happens in the block stays there. When we get out of the blocks, it forgets it. And you know about the difference between static type of variable type and the normal one that we defined before now. Please go through this example again and again. At the beginning, it seems complicated, but I'm sure if you guys go through it, uh, you will learn a lot from this example. This one is very useful. But guys, I hope this session was useful for you. You can ask us your questions during the online session that we will have or by using email. See you guys.